तो फ्रेंड्स आज हम पढ़ेंगे फन विद मैग्नेट. Some things exciting was happening. A crane was moving towards the heap of junk. The long hand of the crane lowered a block over the heap. It then began to move. Many pieces of iron junk were stinging the block as it moved. They had just read a very interesting book on magnet and knew immediately that you might have seen magnets and have even enjoyed playing with them. Have you seen stickers that remain attached to the iron surface like almirah or the door of the refrigerator? In some pencil boxes, the lid fit tightly when we close it, even without a locking arrangement. If you have any of other item, try to locate the manage hidden in these. About how magnets were discovered. It is said that there was a shepherd named Magnus who lived in ancient Greece. He used to take his herd of sheep and go to a nearby mountain of grazing. He would take a stick with him to control his herd. The stick had a small piece of iron attached to one end. One day he was surprised to find that he had to pull hard to free his stick from a rock on the mountainside. It seemed as if the stick was being attached by the rock. The rock was a natural magnet and it attracted the iron tip of the shepherd's. It said that is how natural magnets were discovered. Such rocks were given the name magnetite. Perhaps after the name of the shepherd, magnetite contained iron. Some people believe that magnetite was the first at the place called magnesia. In any case, people now have discovered that certain rock have the property of attaching piece of iron. They also found all pieces, small pieces of these rocks have some special property. These are known as artificial magnet. Nowadays, artificial magnet are prepared in different shape. For example, bar magnet, horseshoe magnet. अब हम एक प्रैक्टिकल करेंगे. टेक a plastic or paper cup fixed on a stand with the help of the clamp as shown. Place a magnet inside the cup and cover it with the paper. Know that the magnet is not visible. Attach a thread to a clip made of iron. Fix the other end of the thread at the base of the stand. Bring the clip near the base of the cup. Clip is released in air without support like a kite. Magnetic और नॉन मैग्नेटिक मटेरियल. अब हम एक प्रैक्टिकल करेंगे. वॉक इन ए फुट स्टेप ऑफ मैग्नेट्स. ओनली दिस टाइम वी will change the position of the magnet and the iron. There a magnet at the end of our shepherd stick. We can attach a small magnet to hockey stick, walking stick आदि. Let's now go out on a magnet walk through the school playground. What does our magnet stick pick up from the school ground? Collect various objects of day by day use from the surrounding. Touch these with the magnetic. You can also take a magnet, touch these objects with it and observe which objects stick to the magnet. Look at the last column and then note the object that are attracted by the magnet. Material from which these objects are made. It is there are many material common in the all objects that were attracted by the magnet. Of the material which get attracted towards the magnet are magnetic. For example, iron. The material which are not attached towards the magnet are non-magnetic. अब हम एक प्रैक्टिकल करते हैं. रब ए मैग्नेट इन द sand or soil. Pull out the magnet. Are there some particles of sand or soil sticking the magnet? Now gently shake the magnet of the remove the particle of sand or soil. Are some particles still sticking to it? These might be small pieces of iron picked up from the soil. Through such an activity, we can find out whether the soil or sand from the given place contain particles that have iron. Make a table of what you find. If you fill this table and sand it, they can compare the amount of iron fillings found in the soil and above poles of magnet. We observe that the iron filling, if they are present, stick to arrange magnet rubbed in the soil. Practically, they spread some iron filling on a sheet paper. Now place a bar magnet on the sheet. What you observe? Do the iron filling get attracted to some parts of the magnet than of others? Remove the iron filling sticking to the magnet and repeat the activity. Do you observe any change in the pattern with which the iron filling get attacked by different parts of the magnet? Draw a diagram to show you way iron fillings stick the magnet. We find that the iron fillings are attracted more towards the region close to two ends of the bar magnet. Poles of magnets are said to be near these ends. Check for the location of the poles on these magnets using from iron fillings. Can you know now mark the location of poles in the kinds of magnets by finding direction? Magnets were known to people from ancient time. Many properties of magnet were also known to them. You might have read many interesting stories about the use of magnet. One story is about an emperor in China named Hong Tai. It is said that he had a chariot with a statue of a lady that could rotate in any direction. It had an extended arm as if it was showing the way. The statue had an interesting property. By looking at the extended arm of the statue, the emperor was able to locate direction when he went to new place on his chariot. Let's make such a direction finder for. Take a bar magnet, put a mark on one of its end for identification. Now tie a thread at the middle of the magnet to so that you may suspend it from a wooden stand. Make sure that the magnet can rotate freely. Let it come to rest. Mark 2 points on the ground to show the position of the end of the magnet when it comes the rest. This is line so the direction in which the magnet was pointing in its position of rest. Now rotate the magnet by gently pushing one end in any direction and let it come to rest. Again mark the position of the two ends in this position of rest. Does the magnet now point in a different direction? Rotate the magnet in the other direction and note the final direction in which it come to rest. Repeat this activity with an iron bar and a plastic bar on wooden scale instead of a magnet. Do not use light object for this activity and avoid doing it where there are a current of air. We find that a freely suspended bar magnet always come to rest in a particular direction, which is the north-south direction. Use the direction of the rising sun in the morning to find out the rough direction towards east where you are doing this experiment. If you stand fact east to your left will be north. Using the sun for finding direction may not be very exact, but it will help to make our out the direction north from the south on your line. Using this, you can figure out which end of the magnet is pointing to the north and which point of the south. The other end that points toward the south is called south seeking and or the south pole of the magnet. All magnets have two poles where their shape may be usually north and south. This property of magnet is very useful for us for centuries. Travelers have may been making use of this property of magnet to find direction. Later on, a device was developed based on this property of magnet. It is known as the compass. A compass is usually a small box with a glass cover on it. A magnetized needle is pivoted inside the box which can rotate freely. The compass also has a dial with direction marked on it. The compass is kept at the place where we wish to know the direction. I will make your own magnet. There are several methods of making magnet. Let's learn the simplest one. Take a rectangular piece of iron, place it on the table. Now take a bar magnet and place on its poles near one edge of the bar of the iron. Without lifting the bar magnet, move it along the length of the iron bar till you reach the other end. Now lift the magnet and bring the pole to the same point of the iron bar from which you begin. Move the magnet again along the iron bar in the same direction as you did before. Repeat this process about 30-40 times. Bring a pin or some iron fillings near the iron bar to check whether it has become a magnet. If not, continue the process for some more time. Remember that the pole of the magnet and the direction of its movement should not change. You can also use an iron nail, a needle or a blade and convert into magnet. Magnetize an iron needle using a bar magnet. Now insert the magnetized needle through a small piece of cork or foam. Let the cork float in water in a bowl or tub. Make sure that the needle does not touch the water. Your compass is now ready to work. Make note of the direction in which the needle point when the cork is floating. Rotate the cork with the needle fixed in it in different direction. Note the direction in which the needle points when the cork begin to float again without rotating. About attraction and repulsion between magnets. Let's play another interesting games with magnet. Take two small toys car and label them A and B. Place a bar magnet on top of each car along its length and fix with them rubber band. A car, keep the south pole of the magnet towards its front. Place the magnet in opposite direction in car B. Now place the two cars close to one another. The car run away from each other. They move towards each other and collide. Record your observation in a table is shown. Now place the toy car close to each other such that the rear side of car A face from the front side of the car B. Note the direction in which the car move. Now next place the car A behind car B and note the direction in which they move in each case. With their rear side facing each other, record your observation in inches. This property of magnet can also be observed by suspending a magnet and bringing one by one the poles of another magnet near it. A few questions. Magnets lose their properties if they are heated, harmed and dropped from the some height. Also, magnets become weak if they are not stored properly. To keep them safe, bar magnet should be kept in pair with their unlike poles on the same side. They must be separated by a piece of wood while two pieces of soft iron should be placed across their ends. For horseshoe magnet, one should keep a piece of iron across this pole. Thank you.